My name's Leo. I'm the owner of Orchard Audio. I do have a presentation, but before I start the presentation, I'm going to just show my products so that you guys can get a better understanding of the size of the products, because I do get a lot of questions for that. So I'm going to start off with the amps. So here is the amp. So as you can see, they're monoblock amps, and as you can see, it's pretty small. And they come in two versions, which I'll go over in the presentation. This is the inline version, which allows you to put the amp right behind the speaker and sort of just hang it on very short speaker cables. These are the speaker cables that I sell, and they come with locking banana plugs. So the amplifier's on there. It's not going anywhere. And one of the reasons the amplifier is so small is because this is the power supply. And as you can tell, the power supply is about the same size, and it's actually heavier than the amp. And anyway, so that's the power brick. And then this is just the enclosure for my latest product, the Star Crimson integrated amplifier. So the integrated amplifier basically combines my BOSC monoblock amps and combines my PecanPi DAC into one product. So that's about the size of the and then streamer, we'll just hold it out here. So this is the streamer. It has the volume knob on the front, and just XLR outputs on the back, and it comes with XLR to RCA adapters, which you'll also get into as part of the presentation. So as you can see, my products are very compact, but hopefully, as some of the members who've tried the products, you know, they're compact on size, but not on performance. Anyway. Okay, so I'll start sharing my screen to do the presentation. Okay. So I guess thumbs up if you guys can see the presentation. Okay, perfect, thank you. This is just the slide with my contact info for anybody who wants it. You know, you can give me a call, send me an email if you have additional questions after the presentation. Okay, so Orchard Audio came about. Actually, I started Orchard Audio in 2017, but way before that, I designed a audio system for the house. Because at that time I was looking for something that was very high performance, but I couldn't find anything at the price that I was looking at. So I ended up, you know, designing my own stuff, which in the end probably ended up costing a lot more than just buying something that was off the shelf. But in any case, as people came over, as friends came over, everybody said, you know, this sounds great. And then so in 2017, I decided to try basically commercializing the technology and, you know, making upgrades to it over time also. So the plan is to have Orchard Audio basically support me in the future, and to be able to quit my daytime job, which I still have. The company's been bought multiple times. So I'm currently with CACI, and it was LGS Innovations before that. And before that, it's the leftover of Bell Labs. So anybody who's familiar with Bell Labs will know about that. So I have a master's in electrical and computer engineering from New York Institute of Technology. And I worked for a bunch of companies, NASA, Lockheed Martin, Siemens, designing a slew of different products, you know, fire alarm systems, military stuff, space stuff. So, you know, I have very broad knowledge, and, you know, it gives me maybe somewhat of a different perspective when I design my products, you know, for reliability and for some, you know, stuff like that. And I also hold multiple US and international patents, which are actually related to audio, that came out of my work for fire alarm systems, which do announcements throughout the, you know, throughout the building. When like a firefighter comes in and they pick up a handset and they have to say, all right, this floor, evacuate this way, et cetera. Anyway, so when I was working for Siemens, that was probably about 10 years ago now. That's when my whole interest with audio started, because that's when I started to design audio products. So my methodology goes in line with famous Leonardo da Vinci quote, "Simplicity is the ultimate sophistication." And with that, the fewer parts that are in the audio path, the less noise there is, the less distortion is introduced. And my main goal is to achieve very high levels of measurable performance, which I believe will translate into subjectively good results. So this is also the reason you're not going to see too many features in my products. My product features audio performance. That's the feature that you're getting, essentially. You know, it's not going to have like a million knobs on it. It's not going to have a million features, but you get very good performance. And this also allows me to keep, you know, prices down, as I'm a very small manufacturer. I don't have large volume at the moment. So I have to keep keep prices down as much as possible. So this is a picture showing a fully completed Stark Crimson integrated amp. On the back, one of the things that this has that a lot of other products don't is the DAC output is available, and so are the amplifier inputs. So if you want to use the internal DAC, you just jumper the DAC into the amp, and it's a self-sustaining product. You just add speakers, and then you need your digital input, either USB or SPDIF. So it's currently on sale for $19.95, but the price is going to go up to $24.99 in the future. Okay. So the PecanPi streamer, all my PecanPi branded products have the same DAC. It's the PecanPi DAC, I should say, and the PecanPi streamer is high performance network music player. It's built on top of a Raspberry Pi, for those who are familiar with what a Raspberry Pi is. And it supports up to 24-bit 192 stereo, and it has an XLR output, and the RCA output is using the adapters. It also has a built-in headphone amplifier, which is yet another adapter that you can get that plugs into either the XLRs, which gives you balanced headphones, or you can plug the headphone adapter into the RCA sockets and for your regular type headphones. So the streamer supports 4 different software options. Volumio, I would say, is the second most popular option that I sell the streamer with. It has a lot of built-in functionality, including UPnP and DLNA. It's also an AirPlay renderer for those who have Apple devices. Due to AirPlay limitation, that's only limited to 16-bit audio, but everything else is 24-bit. You can get my Volumio to get native Tidal and Qobuz integration for those that have those streaming services. if you don't want to pay the MyVolumio fee, which I think is like $3 a month, there's a way around that with Bubble UPnP, which is an app for your phone, which is basically a UPnP server. So your phone basically sends UPnP data to the streamer, and the streamer plays. And then on your phone, you can do Qobuz and Tidal, and there's no additional monthly fees. So that's one way to get around MyVolumio if you want Qobuz and Tidal integration and don't want to pay a fee. Anyway, Mood Audio has very similar functionality to Volumio. Mood Audio is targeted more for techie individuals who like to tinker, change settings, stuff like that. But functionality-wise and audio quality-wise, it's identical to Volumio. Pi Core Player, for those that still have Logitech Media Server and Squeezebox touches, the streamer can essentially be a Squeezebox replacement minus the touch screen, but you control it using your phone instead. So you don't really need the touchscreen in that scenario. And at the end of the presentation, I'm actually going to show how the streamer functions and its user interface. The Roon endpoint, that's the most popular option for my devices. A lot of my customers have Roon, and you know, if that's something you're going to invest in, then the Roon endpoint it's an endpoint only. It won't be the core, so you still need a core on your network for that to work. The PecanPi USB is another product. So this case is the same size as my BOSC amps. It uses the same DAC, and it provides for a USB input. The streamer can only act as a network device. I get this question a lot. The streamer cannot act as a USB DAC, even though it has USB connections on it, as you can see here. These USB connections are to connect USB storage devices to it, you know, thumb drives, hard drives, CD-ROM drives, to play your music. So it's the same exact DAC and provides for a USB input. So if you already have a dedicated laptop that you use to play music, or a dedicated computer that you use, you know, this is the better way to go instead of the streamer. Same thing it's the same DAC, so it also has the headphone amp in there. And here you can see the XLR to RCA adapters that come with both this and the streamer. This is what the PecanPi DAC itself looks like, and it's also available for sale as the board, so that you know, for the do-it-yourself enthusiasts, you know, you can get the Raspberry Pi on your own, put it together, or do something else with it. Essentially, on this header, it's just I2S. So if you put I2S into it, it'll you know, it'll work. So here are the dual Burr Brown or Texas Instruments PCM 1794As. They run in monaural mode. And then here are the output stages with my proprietary filtering technologies. And then it goes out to the connector. And from here to the connector, it's about 1 inch. So the audio path is very short, keeping audio components at a minimum, you know, like I said, to go with my methodology. And everything here is analog, and everything on the other side is digital. So digital noise is kept away from all the analog circuitry. And all the analog stuff is powered by 1, 2, 3 linear regulators. So I also get a lot of questions for, you know, if I upgrade the power supply that plugs external to the unit to a linear one, will it help me? In this case, the answer is no, because there's linear regulators already there. So a linear regulator plus a linear regulator is not gonna do much for you. This is what the back of the board looks like, and these are the headphone drivers. They're on the back. You can see there's 4 of them. That's the DAC. So this is just sort of what I went over. It uses Burr Brown's flagship DACs in monaural mode, which also allows me to use full dual differential output stages. So it is, the XLR connector is a true balanced output. It has a very low jitter oscillator on there. You know, any of the jitter that comes from the Raspberry Pi is eliminated. If you buy it and you connect any other source to it, it'll eliminate any jitter that gets you know, that gets plugged in. So with the USB DAC, the jitter is also removed. So there's no worry about jitter on USB, which is usually there's a lot of that. So like I said, 3 low noise linear power supplies. As you can see, they're very low noise. And then the headphone drivers, dual parallel 1622s or quad parallel if you're using balanced headphones. So I'm gonna get into the test results for the PecanPi DAC. So what you'll notice here is this is on the left side, I have total harmonic distortion, and here is frequency. So the DAC has very good control across the whole frequency range. Minus 110 dB equates to 0.0003% distortion. Or another way to look at it is it achieves 99.9997% accuracy. So you want to get to 100%, but 100% is not achievable essentially. So you want to try to get as close as you can. So anyway, this DAC is pretty much there, and it has very good control across the whole frequency range. Skipped a couple slides. So this is the frequency response of the device. So you can see it's essentially completely flat out to 22 kilohertz. This is actually a limitation of the sampling rate that this test was done at. This test was done at 44.1 kilohertz sampling rate. So the Nyquist rate is 22 kilohertz. So the device, if you send it 192 kilohertz files, actually has completely flat bandwidth out to 96 kilohertz, which is half of the 192, and it is DC coupled, so you get no base phase shift, and you know, like a lot of other devices, and there's no decrease all the way down to DC or 0 hertz. So this is the linearity of the device. What's a good way to explain linearity? Linearity is how true the audio stays across the whole band of power levels, and it's measured from minus 120 out to 0 dB, which is full output power. And the device does start to lose linearity a little bit below 110 dB, but at that point, I would say it's well below the noise floor of any room that the device would be used in, unless you have an anechoic chamber. So it essentially becomes irrelevant out here. So you get very high purity through the whole power band of the device. And this is showing intermodulation distortion versus output level. So intermodulation distortion is how well the device reproduces multiple frequencies, right? So audio is not just a 1 kilohertz tone, or audio is not just a 2 kilohertz tone. When you're listening to music, it's it's a mixture of all different tones, and it's important that no matter how many tones you have, right, each tone should have a very high level of clarity. Basically what this shows, you get minus 100 dB performance at minus 25 dB and better, which is where most people listen to their equipment. Is probably about in the minus 25 to minus 20 dB setting range. As you go lower in level, the noise takes over, and that's why this is almost like a straight line, because as you decrease, because the noise floor always stays the same, but as you decrease level, your distortion increases. And this is going to be true of any DAC that's available on the market. As you get lower and lower in its output, it's going to have more and more noise relative to the output level. This is the jitter and noise spectrum. So jitter is what determines how well the music has Pratt, or pace, rhythm, and timing. So this is where, for the PecanPi, because it does the reclocking with the ultra low jitter clock, the jitter performance is essentially very good. The noise floor is minus 170 dB, and any spikes are below 140 dB, which is basically inaudible. So it has some of the best jitter performance amongst devices at any price on the market. So I did put in one slide for as a sales pitch. I'll spend very little time here, but basically this shows the device, the SINAD of multiple devices, and the dynamic range of multiple popular devices on the market. And here is the price. And as you can see, the PecanPi at the price at which it sells, I believe is very well positioned based on performance. And all of these numbers I got from Audio Science Review. From those who are familiar, it's a very reputable site that does third-party testing of manufacturers' devices. Anyway, so I'm going to move on to the monoblocks, which are $749 a piece or $1,500 a pair. I don't think I've ever had a person buy one. Everybody always buys them to get the stereo pair. So and the picture shown here is with the all connectors on the back. The one that I showed during my initial presentation, that was the inline version, where the outputs are on one side and the power and input are on the other. Like I said, that's made specifically so you could put them in line with your speaker, like right next or right behind the speaker, essentially eliminating speaker cables and getting a powered speaker in a sense. I think I have a picture of that coming up. Um, so they use the latest technology, including gallium nitride. Gallium nitride is came around about 67 years ago, and it's slowly but surely eventually going to replace silicon devices. And the reason I say eventually is because it's still a relatively new technology, so there's still a price premium on it. So not all manufacturers are using it, but it's becoming more and more popular. And it's also what allows me to have a very compact device, because they also offer super high efficiency. Okay, yeah, so this picture shows the inline version where the outputs are on one side and the inputs are on the other. And here you can see a picture from a customer of mine where it's a very short speaker cables. These are, I think, like 6 inches long, and you know, essentially eliminating the need for long and expensive speaker cables. And as many of us know, some spend on speaker cables more than these amplifiers cost in any case. But all right, so keep going. Okay, for those who may not be familiar, Class D does not mean digital. Over the years, it has become synonymous with that. Class D means switching amplifier. And in this respect, BOSC is a purely analog amplifier. So it has no digital processing whatsoever. The pulse width modulation is determined completely in the analog domain, and then it's amplified by the GaN, by the gallium nitride power stages. And in this respect, it's set apart from a lot of its counterparts that do use digital modulation techniques inside of, you know, FPGAs, digital signal processors, etc. So it's not the only completely analog amplifier on the market, but Class D analog amplifiers are becoming a dying breed because of all, you know, the increasing processing speed of digital devices. But anyway, so BOSC is a fully analog amplifier. One of the reasons it has its unique sound also. BOSC works with my proprietary dual feedback self-oscillating technology. It doesn't use any, you know, Hypex, Encore, ICE, or any of these other off-the-shelf type Class D chips, as you would call them. So it's completely my own modulator design that I've developed, you know, and recently I introduced the gallium nitride to it to make these amps. And again, the amplifier is DC coupled, just like my DAC. With the two products combined, you get no bass phase shift at all. There's other products that very few amplifiers are DC coupled, and it's because it's very difficult to keep DC under control. But in these amps, the DC offset is only a couple of millivolts. But you also have to keep in mind they'll amplify any DC that you put into them by their, you know, by their gain. So this is what a BOSC module looks like. Joe, I think you were holding one up in your hand earlier, so you could tell how big it is. Yeah, Joe tried the amps and bought a couple of modules to do his own do-it-yourself build. But anyway, gallium nitride provides multiple benefits over the traditional silicon transistors for Class D amplifiers, which I list here. I don't want to get too much into it, but essentially this is due to the increased slew rate, reduced ringing, faster switching speeds and faster overload recovery of gallium nitride transistors compared to their silicon counterparts. And I'm going to go a little bit more into on the next slide, but for a Class D amplifier, the output filter is an extremely important part of the design. And as you can see here, these are the two inductors for the filter and the capacitors on the other side, which you'll see in another picture that I have. But the inductors and the capacitor are extremely oversized for what is actually needed for the power level that BOSC makes. And the reason they're oversized is because it allows the amplifier to have a lot more linearity through a part of the power band where most of the listening takes place. So I'll show that in later slides. So these two little things here. Those are actually the GAN power stages, and the modulator is in this area. And again, there's two very low noise linear regulators for everything to do with the modulator and the low level analog signal before it gets amplified by the GAN devices. So here's a picture of my modulator. It has both pre and post filter feedback. A lot of Class D amps, they only do pre-filter feedback. The post-filter feedback has an advantage where it essentially takes the load out of the equation because there is feedback from the load. The reactance of the speaker doesn't have any effect, essentially. It's completely taken out of the equation. So whatever speaker you power, the amplifier is going to get its very high level of performance. So like I said, okay, so I talked about this before, right? So the gallium nitride devices allowed this, in my case, the amplifier to switch at around 800 kilohertz, which would be next to impossible for traditional silicon devices. And it also allows me to use a traditional single pole LC filter, which allows to have no phase shift out to 30 kilohertz. A lot of Class D amplifiers suffer phase shift problems because their switching frequency is more in the 300 to 400 kilohertz range. And this filter needs to be put very close to the audio band to eliminate the switching frequencies from the output. And because of that, traditionally Class D amplifiers have a lot of phase roll off, you know, like above 6-7 kilohertz. With this amp, no phase roll off till 30 kilohertz essentially. Here's graph showing that. So this is the frequency response of the amp. So you can see it's completely flat on the level out to essentially, well, it goes up a little bit at very high frequency, but it's flat through the audio band. And here's the phase shift. And the phase shift is also flat. You know, it starts rolling off slightly at 30 kilohertz. At low frequency here, this phase shift doesn't actually exist. The audio analyzer is AC coupled. So this phase shift is actually being introduced by the audio analyzer, not by the amp. And here's the distortion versus output power. And as you can see here, distortion stays below 110 dB from 5 watts all the way out to 50 watts. And this is where those oversized inductors are doing their job. you know, very low distortion in this area, which is where most of the listening takes place. Rarely, you know, when you do regular listening, are you going to be driving the amplifier at full power? And even if the peaks are at full power or the transients are at full power, you know, most of the power is going to be concentrated down in this area. And again, just like with the DAC, as you go lower and lower in output power, the noise stays the same. So your distortion goes up. And again, this is unavoidable for any type of amplifier. But with BOSC, even at, you could see at very low power levels, this is a 20 milliwatt. Even at 20 milliwatt, the distortion is below 85 dB here because it has very low noise. And this is distortion at 10 watts over frequency. So again, you can see here, the amplifier has exceptional control over the whole audio band. You know, the distortion stays exceptionally low, even at 10 watts. This is, again, due to the oversized filter. And here's the what a 1 kilohertz FFT looks like. So here's the noise floor of the amp. It's 150 dB down from its full output level. And as you can see here, the harmonics are below 130 dB. So again, in 95% of situations, this is well below any noise floor in your room that you would have, unless you have like a very special, you know, setup room with noise dampening and maybe like, you know, special acoustic panels to bring the noise floor in the room extremely, you know, extremely low. And this is intermodulation distortion. Again, at regular listening levels, which are probably going to be in the -25 to -20 range, where we're at around -100 dB. So again, the amplifier has very good performance, not at only a single frequency, but when it's presented with multiple frequencies. And again, I did a chart for comparison for BOSC performance versus some other popular amplifiers on the market. So as of current, there are very few Class D amplifiers with GAN devices. There's a few others not listed here, but they're also at these types of prices. So as you can see, especially considering that I'm offering GAN technology and the performance level, you know, I believe the cost is, it's very well positioned against competitors. I don't know how these amplifiers perform. I was not able to find the specs. So anyway, but you could see other GAN amplifiers will cost you arm and a leg and maybe plus a little more. Okay, so that's it for my presentation. I'm going to open up for questions, and here's a 10% off code for anybody who's interested. And after the Q&A session, I'm also going to do a presentation of the of my streamer and its interface with Volumio. But I'm going to open it up for questions. I guess if you can unmute yourself, you know, and then, you know, ask whatever questions you have. And then I can go back through the different charts or different pictures in the slides if you have any specific questions to that. Oh, I guess, Paul, are you getting questions over text?
I've got some comments here, although nothing I would consider to be a bona fide question. I have a couple of questions myself.
Okay.
If no one minds me jumping ahead, I was curious where your manufacturing is done. I mean, is it literally, you partner with someone near where you live, or I mean, where's this stuff made?
So the PecanPi DACs are made in Canada. The BOSC camps are actually manufactured in New Jersey. The only thing that's made in China is the circuit boards themselves, but assembly of the circuit boards is done in New Jersey or Canada. And then, I get the circuit boards and my volumes are still low enough. I do personally the final assembly of all the products, and I do the testing myself also.
Wow, that's kind of cool. I mean, you sign them too. Has anyone asked for that?
No, nobody's asking.
No. It's kind of a cool Easter egg. You open it up and then see. What about your home system? I'm just curious because you said you built a whole house audio system. But I mean, do you have a 2-channel rig? And if so, I mean, what does it comprise? I imagine it's your stuff, but I'm just curious.
Yeah, so I mean, today it's the USB DAC and 2 of my BOSC cams. That's what it is today. But when I first started, it was a DAC based on the same, actually PCM 1794A chips. They're old, but I believe their performance is, very good. And to get something better is going to be a lot more money for performance that is really only fractions better, perhaps. And I also really like the way that the PCM 1794As sound compared to the ESS devices. ESS would be the only other company that makes something that's higher performance, especially when it comes to dynamic range. And then my original modulator is very similar to the modulator that I use now, except my new modulator adds the post-filter feedback and the gallium nitride devices into it. Yeah, 10 years ago, I didn't use gallium nitride, and switching speed was much slower. So basically, been improving on my technologies for 10 years, even though the company's was only started in 2017. So they're very mature, very stable. Even with the gallium nitride, I first started with that maybe 3 years ago. And the first time I made an amplifier with it, it blew up. Because gallium nitride has a lot of challenges. Or maybe not challenges, but there's a lot of differences from standard silicon devices. So the way you treat them has to be completely different, as I learned. But anyway, I'm very familiar with the gallium nitride devices, and I believe I'm a step ahead with manufacturers who are just starting to use them now.
I totally agree on that. I had another question, just a little housekeeping. Would it be possible to end the presentation just so we can, when we do the Q&A, we can see each other's faces?
Oh yeah, sure. I'll stop sharing my screen. Okay.
Perfect. Not a bad thing. It's just like, you were like in this little tiny box.
Okay.
All right. So here's one from a club member who's asking, which Raspberry Pi is inside the streamer? Is it the Raspberry Pi 4? And if so, why no USB 3 ports for external storage?
It's not a USB Pi 4. It's not a Raspberry Pi 4. It's actually a Raspberry Pi 3. Depending on what's available, it's either a 3 or a 3B plus. I don't use the 4 because the 4 does not get you any better audio quality, and it generates a lot more heat. And so to basically save power, I use the 3B devices. And with audio, USB 3 speed is not needed anyway. 24-bit, 192 kilohertz files are well below the bandwidth of USB 2, well below.
Awesome. Well, unless anyone else has other questions, I'm going to keep banging away at you, Leo, because I have plenty for you.
Okay,
I'm curious, sure. Because you have, these small devices that are amplifiers, and you build a DAC, if you've ever considered producing an active speaker.
I have considered partnering with other companies, and as of so far, that has not happened. But I'm still working with a few companies. I can't name them because of non-disclosure agreements. So you may see myself in active speakers in the future. For me personally, I understand enough about how speakers work and what they do, but I don't have enough knowledge to design my own speaker from scratch. So I'm gonna focus on what I do best right now, which is the electronics.
Leave the active stuff to me.
All right. Well,
I got a couple of questions, but I wanted to let the other members have a chance first. So if anybody else.
Yeah, please, if you have questions, folks, please type them into the chat. Otherwise, me and Joe are going to dominate here.
Yeah.
And it'll be what it'll be. But until I see another one pop up, I had another question for you, Leo. When you showed us that chart and you talked about jitter, and there was, it showed like the noise floor, I guess, or there were some spikes around what seemed to me 12 kilohertz. Was that the test tone? Is that why that particular spike was basically way off the chart, and then everything else around it was compressed down? I mean, was
right?
That,
so the 12 kilohertz is the test tone, and it's not a regular sine wave. It's a very special 12 kilohertz test tone that's specifically made to test jitter of devices. You can read about it online. I'm not going to get into too much specifics, but yes, in an ideal world, the only thing you want to have sticking up out of the noise floor is the 12 kilohertz tone. So that would be, zero jitter, I guess, if that's what you want to call it. There's really no such thing as zero jitter. And the other spikes that you see there are actually artifacts of the DAC doing, processing on the audio. But like I said, all those spikes were below 140 dB. So it's completely, it's completely inaudible.
Got it. Yeah, I just want to understand it because I'm not used to those charts. So I just want to make sure I understood it, and if anyone else.
Yeah, and the reason you do it at 12 kilohertz is because jitter presents itself more at higher frequencies, and the sample rate is in that particular case it was 48 kilohertz, right? So it's done at 12 so that you could potentially see the highest harmonic, which would be the 24 kilohertz would be the next harmonic.
Makes sense. All right, well, we have a question from a club member here. Keith is asking, what is the amplifier's output into various speaker loads? So I guess that would be like 8 ohms versus 4 ohm versus 2 ohm.
Yeah, the amplifier is rated 150 watts into 8 ohm. It'll drive all the way down to 2 ohm. It'll even drive down to 1 ohm. But yeah, the way that I sell them, it's 150 watts, regardless of what ohms you put on them, right? So I know in a lot of amps, it would be like 150 into 8, 300 into 4, and it keeps doubling as you keep halving the impedance of the speaker. And, you know, if you buy the do-it-yourself modules and you heat sink the amps, you can get more power out of them into 4 ohms. You know, and actually in my case, my power supplies are only 250 watts. So you wouldn't get more than 250 watts out of the amp anyway. And I do that because there's no heat sinking, you know, on the modules. So it's to prevent the amplifier from my version of the amplifier from overheating.
I was going to ask you that about heat sinking because I noticed there was none. So a do-it-yourselfer could add heat sinking and then configure the amp to produce more power, I guess, with the add of a power supply.
Well, you don't configure the amp to produce more power. It's already capable of producing that power, right? And as Stuart says over there, who did a review in Audio Express for me, he had no issues with 250 watts into 4 ohms. I don't advertise it because, you know, in like 99% of scenarios, even if you get 250 watts, when you're listening to audio, it would be for very short periods of time. And over very short periods of time, the amps are not going to have any problem with it.
Mm.
But, you know, I guess being cautious, I rate the amps at 150 watts, you know. And
So that kind of leads into the next thing. What about 2 Saturdays ago, Leo and I had a 6 a.m. Arizona time, 9 a.m. his time Zoom chat, just because I had a ton of questions for him. So what I'm working on with a lot of help from Leo is I'm basically the BOSC amps that you see. Well, we can't call them BOSC now, right? Because Bosch tried to.
I forgot to mention during my presentation. Yeah, so
Yeah.
BOSC is going to change from BOSC over to Star Crimson. So like I have the Star Crimson integrated. So BOSC is going to become BOSC Mono. Star Crimson Mono is going to be the name, but the you know, the amps and the technology is all going to be the same. It's just going to be a name change.
Yeah.
So those guys the automotive guys, the ones that produce parts for Audi and Volkswagen and all that, they got on you about that name, even though your whole theme is around.
Well, actually, BOSC does also have audio products, and that's part of the. It's maybe not for high-end audiophiles. Is not their target with their products, but they do have audio products. So, but
I'm not going to buy their spark plugs anymore.
There we go.
Shame on them for going after you.
So
Keith is asking a question about if your DAC does DSD.
no, the DAC does not do DSD. So whatever software you use with my products, in any case, it's going to do DSD to PCM conversion, and then the DAC will, you know, play PCM. And I did have a couple of reviewers who actually said, even though the DAC did not natively support DSD, it still sounded better with the DSD to PCM conversion than the PCM equivalent files. So, I mean, you know, but that's subjective, right? So,
That's a can of worms right there.
yeah. I'm not even gonna. So what I've been working with Leo is I'm gonna run his amps at 300 watts. And again, this is not recommended for anybody to do in the club here right now until I get this thing to work right. So Leo's already told me on more than one email, 54 volts DC, and as many, like I think I ordered 800 volt amp power supplies, but at any rate, you need a shit ton of current, right? But the 54 volts, just like Leo said, don't stray from it. You know, don't try to push it higher, or else I'm going to have $600 worth of bricks on my sofa. So there's that going for it. And the other conversation that I had with Leo was his amps sound amazing, right? On my Kefs, on the bass drive, or basically the upper modules here, wherever the hell they are. But I had a hell of a time with the bass drivers. There just wasn't enough oomph to, you know, for them to sound good. But again, the whole, you know, upper treble, it was basically, I got rid of my PS audio amps because of this, right? And I'm not just saying that because him and I got a mutual friend in New Jersey. They sound really good. I mean, you know, I got nothing bad to say about it. The other issue we had, though, was with these fucking 901s. I couldn't get it to drive them to save my life, and that's because of the EQ curve, right? But any kind of normal loads, like Paul's Tectons that he had at the music night thing, they sounded fucking amazing, right? Same thing with my Kefs. These little ohm Walshes back here, no issues whatsoever, but you give them a really nasty load and they have a hard time. That's why I'm hoping if I can get this 300 watt version to work nice on the top part, then I'll just order another pair to drive the bass drivers with.
Well, and the other thing to keep in mind too is that my amps are rated RMS,
Yeah.
right? So when you consider RMS versus peak power with a sine wave, for example, the peak power of a sine wave is actually 2 times that of the RMS value. So the at 150 watts, when you're playing a sine wave, the amps are actually putting out 300 watts peak. Like you said, when you do 300 watts, it's actually 600 watts.
Correct.
Peak.
Correct.
Because the peak value is always double the RMS value for sine waves. So, I mean, depending on which manufacturer you ask, some rate their amps peak power.
Yeah, which is bullshit. That's
RMS.
right. No, RMS is better.
So mine are rated RMS, but they will do 300 watts peak. There's actually the power supplies that I sell them with, even though they're rated 250 watts, there's enough capacitance between the power supply and what's built into the amp to provide 300 watts for the period of time that's needed to, you know, still keep distortion low, you know, and not overcurrent the devices, you know.
Yeah, and
like,
I did order some heat sinks too for it. So again, I haven't, until these power supplies come in, Leo, I'm not going to touch them, right? And then everything I'm going to do is going to be outside the speaker cabinets. I'll have a thermocouple set up, monitor the temperature and all that fun stuff. So I'll get you all that good feedback once I got everything fired up over here.
All right, I see a question came in from somebody. So the question is, do the amps require external power supplies and do I have to provide them? So the answer is yes, they do need external power supplies, and no, you don't need to provide them. The $1,500 gets you the amps, the power supplies, and the XLR to RCA adapters. And I can show you them now since you missed it. So this is the inline version of the amp, which has the speaker connectors on one side. I also have another version where all the connectors are on the back for the more traditional setups. And this is the power supply that the amps come with. They're 56 volt, 250 watt bricks.
Leo, I noticed you have 2 configurations on your amplifiers. You talked about an inline version and then a traditional style. So I'm curious if you have an opinion on speaker cable length versus internet connect cable length. And, you know, what is better if someone is going after the inline version? You know, should they try to get short speaker cables and have it right up against the speakers and then run a long interconnect, or the opposite?
Yeah. So yeah, the shorter the speaker cable, the better, and the longer interconnect is what I recommend. Especially, that's the reason that the amps are have an XLR input. With a balanced interconnect, you can run very long distance, no problem. You know.
Leo, that brings me to the next question. You might want to let the guys in the club know that. Remember that whole thing with needing outside of your integrated amp, If anybody's going to run their own preamp into your amps, they need to have like was it 5 volts is what's expected to drive your amps at the power ratings that you specify. If your preamp provides less than that, then your output power is going to drop a little bit. Or did I screw that up?
Well, yeah, so the amps need 5 volts RMS on the input to get them to full power. But in 99% of cases, you don't need them at full power anyway. Unless you have like super high inefficient speakers, or you have like a massive room. But yes, they also have relatively low input impedance of 5K compared to other on the market. So, you know, like passive preamps and some tube amps won't drive them very well because they have very high output impedances. But I am working on an upgrade where the input impedance is going to go up to 40K. So you can look out for that in the future. And with the 40K input impedance, you no longer have to worry about the type of, you know, whether it's a tube amp or a passive preamp or whatever.
Yeah.
You know.
Cool.
I also was curious, I mean, and I'm a layman when it comes to amplifier tech, but I zeroed in on your presentation and you had mentioned that the pulse width modulation was done analog versus digital. And it got me thinking about another chip that operates as a modulator, and I'm not sure if you're familiar with it, but if you are, I'd love to hear the difference between your system and theirs, and that is the International Rectifier IRS 2092 modulators.
2092. I've heard of them, but I don't know what they do. I believe those are also going to be analog, but I'm not 100% sure.
But on like an ICE or a high-pitch amp, you're alluding to that they're using a digital modulator?
Well, I don't know what they use. There's a lot of Class D amps because because it's digital audio, right? So they have a digital input, and then they do the modulation and everything digitally, and then they output an analog signal, right? With my amps, it's analog input only, and there's no digital processing of any sort with FPGAs or et cetera. So it's a fully analog amp. I'm about to look up the, what was it? IRS 2992?
2092.
IRF. So that'd be what, International Rectifier.
IRF 2092. Okay, I see.
Yeah. Yeah, no, I noticed a difference.
Okay, yeah, this is it's pretty old. Yes, that is also an analog modulator. That's not a digital.
Yeah, and I was curious because I know that I actually own a device that like you're talking about that uses a chip called an SAB2403, and it is all in the digital domain, and it has no bass compared to any other amp I've ever used. It's the weirdest thing. So I can see why people may not be fond of the sound of those devices.
Yeah. Yeah, with my amps, the bass is going to be very precise because it's DC coupled. So you're not going to get any roll off in the bass. And also because it's DC coupled, you don't get any phase shift in the bass. So it's going to be, time-wise, like when the bass happens, it's going to be right where it should be presented compared to all the other stuff, right? If you have a lot of bass phase shift, sometimes like the bass and the vocals or the bass and like the cymbal are not going to have the correct timing next to each other, right?
So again, getting back to the amp performance out. So a couple of weekends ago, I was over at New Record Day Ron's place, and he's got your integrated, you know, on loan over there. So we hooked that thing up to a pair of, I can't mention the name because I already gotten into trouble with him once already. So anyways, these are soon to be released bookshelves and tower speakers by somebody this entire club already knows. Sounded phenomenal. It was excellent. Just like I said with my Kefs, which also has Andrew Jones's fingerprint in the crazy crossover, sounded phenomenal. But then we hooked it up to, you guys know Pure Audio Project? They're those funky flat panel speakers that are made in Israel. Well, the crossover design's kind of crappy in it. They look impressive, but your kid could knock the things down. And they sounded like crap. And it wasn't because of Leo's amps. The way this guy's got the crossover designed and the loading and everything else, it was just, you know. So again, as Leo said, if you got a normal pair of speakers, they sound phenomenal. But if you got a, you know.
You mentioned the flat panels. I actually
Yeah, yeah.
customer with Magnapans.
Oh, no, I'm sorry.
Notoriously
Yeah, no, I'm sorry.
difficult to drive,
Yeah,
and
yeah.
they're very happy.
Yeah, no, not even. These were, this guy makes these things out of Israel, and they're these flat panel speakers. They're kind of like a Lego kind of thing, where you could have this super expensive mid-range in the middle, which is what the ones Ron had on loan, or a big horn. And it's an open baffle to make it even worse. And he's got two big 12-inch drivers on the top, two big 12-inch drivers on the bottom, and it just sounded like crap. Now on the reverse, he had a pair of Spatial, I think they're M3s, and it was excellent. You know, again, open baffle speakers, but built like a brick shit house, made in the USA, and it sounded beautiful using the same Star Crimson integrated amp. And again, the guy knows crossover design, so the drive, you know, it worked.
Oh, yeah.
It looks like Stuart has a question that's somewhat technical for you, Leo, on the output impedance of your amps. If you can see it in the chat, I'll let you handle that one.
Okay, yeah. I see Stu's question. The low input impedance of the amps has nothing to do with the DC offset of the amp. It does help with lowering noise, thermal noise, right? So the amps do have 121 dB signal to noise ratio, which is helped by the low input impedance. So
is it an input noise?
It doesn't have anything to do. It doesn't have anything to do with the DC offset.
Well, I was thinking of the offset currents from the input bias currents, but what you're saying here, if I understand it right, is that it's really more due to the current input current noise.
Right. It's due to the thermal noise of the resistors that they were originally low in value. The bias currents on the op amps don't present a problem even with higher valued resistors. But the way the amp works, also the way the gain is structured, is that those resistors partially, not partially, but they set the gain of the amp. Right? And if I were to go to a very high value resistor, the gain of the amp would be super low, which is another problem, right?
Got it. Understand completely. Thank you.
So with my new amps that are going to be that are going to have the 40K input impedance, I'm actually adding a buffer stage to the front of what the existing amp is. So the existing amp is actually not getting changed at all. It's just getting input stage with a 40K input impedance that's going to buffer, that's going to have a gain of 1, and it's going to buffer the audio to the amp as is.
Excellent. Thank you very much.
Okay.
Well, if there are no more questions, I would be very curious to see a demonstration of your streamer interface.
Okay, so okay, so I'm gonna just do a quick pull up on my phone. Okay, so I'll close it. Okay, so the streamer that I showed earlier, it's actually on my network. It's all set up. It comes all set up. So all you would have to do at your house is basically plug in the power, plug in the Ethernet, and then plug it into your amplifier or whatever you have. And then on your smartphone or tablet, you can get the Volumio app. And then, you know, it basically comes right up. This is the home screen that it shows. And then from there, you know, you can browse your audio and stuff. But what I'm going to do, I'm going to share my laptop screen, which is going to show the interface, you know, much larger and easier to see. But it's the same interface you get on your, you know, on your phone or tablet. Share screen. Share. Okay. This full screen. So where do I put this stuff? Okay, so this is what the interface of the streamer looks like when you first plug it in. It brings you to this screen. There's not going to be any track selected because you wouldn't have had anything playing previously. But this is what the interface looks like. You know, you have your play button, you have your go forward a track, go back a track, your standard stuff there. Where is it? So what I have right now is I have a USB drive plugged into the side of the device. So you can browse your USB drive, you know, through its folder structure. You know, this is an album, so I can select the album and, you know, I can play individual tracks over here. You know what, maybe let me just make this slightly smaller like this. So if you click these three dots, you know, you can add it to the queue. You can clear your queue. You can add it to a playlist. You can add it to favorites, etc. If you have media servers on your network that host your library, they'll be accessible through the media servers function. There's web radio. You have radio stations. You can look at even at your local internet stations. As you can see here, I have a lot of local stations that are available. And I went through this playlist earlier. Some of these are actually 24-bit, so it's high res from a web radio station. So media servers. Yeah, you can browse your library by genre. What else is there? Yeah, so you can make playlists. You know, you can save favorite tracks. Like I said, I don't have my Volumio connected, but if you connect my Volumio, that gives you the native Tidal and Qobuz integration, as well as allowing you to connect the USB CD player to the streamer and then play your CD collection. The only thing to note with that is the CD player needs to be externally powered. You can't power it from the USB port on the streamer. It can't provide enough power over USB for like a CD player. And then, yeah, so this is what the play screen looks like. You know, you can adjust volume here, or you can adjust volume using the knob on the device. So my recommendation is, if you're gonna do the software volume control using the app, is that you fully turn the knob clockwise on the device to disable its hardware digital volume control. What else is there? Oh, yeah, here's the queue. So you can see, you know, what you have queued up to play, you know, standard interface for, you know, most devices. I believe that Volumio in the future is gonna, they're saying they're gonna make like a more updated interface. I don't know what that's gonna look like, but as they've done in the past, they always give you the option to choose the classic interface, as they call it. So if you get used to this one, you don't have to worry about it. Under settings, I think it's under system. No, I'm not under system. Where is it? Somewhere. Oh yeah, it is on their system here. So you can check for updates. So as Volumio releases updates, you know, you can get the latest and greatest from them. Volumio is a third party. I just sell my product, you know, with their software. But you know, in my opinion, unless you have Rune, this is the best option. It's very user friendly, easy to use. You know, as far as getting it from me, it comes completely pre-configured, so you don't have to worry about the settings like picking the correct DAC or picking the correct sample rates. It's all automatically already set up when you get the unit from me, right? And depending on the speed of your network and everything, it might take, especially if you have a lot of music, it may take a little while to get the album covers for your albums and for the tracks and all that info, you know, from the internet. But it'll populate, you know, you can see here, I just have a small flash drive for demonstration purposes plugged in. But you can see it automatically finds the cover art for you and everything, you know, and gives you additional information. You could see what quality is playing, you know, sample rate and bit rate here. So that's, I mean, that's my streaming presentation, unless somebody has additional questions.
There is a question asking if Volumio, if that's how you pronounce it, is on the SD card. I use it and I can say, yes, it is. You just flash it and then it kind of takes over, so you don't actually run the Raspbian, you know, native operating system with a Pi or whatever.
Right, and and when you get the streamer from me, I already take care of all that stuff, right? So I just want to make that, I get a lot of questions on it, and the streamer, it does have a Raspberry Pi in it, but you don't have to do any of the do-it-yourself work like configuring Linux or any of that stuff. When you get it from me, it's already configured and ready to go. So basically, you just get the Volumio interface that I showed. You know, yeah. If you just get the DAC and you do it yourself, you have to do all that stuff. But the streamer is a fully, you know, plug and play type product.
I got a question from Keith. He's asking if he can browse network attached storage that isn't running on a server.
Yes, it can access network attached storage. Obviously, the streamer has to be on the same network as your network attached storage.
And I was going to ask you this just because I know it. So since you're using this product as your interface, I imagine you've configured it so that the Raspberry Pi ends up on one server rather than as its own hotspot accessible via like anything that, like you can do a direct Wi-Fi connect, which is how I connect mine. I actually don't even put mine on my network.
Actually, on my units, the internal Wi-Fi of the Raspberry Pi is disabled.
Okay, there you go. So then that's it.
You can only plug it in
a plug-in
with
box.
Ethernet. And I'll show you what I have here. Like, I don't have an Ethernet connection in this room, but I have this Ethernet to or Wi-Fi to Ethernet bridge. That's this is like a $30 device, and this is how I get Ethernet to the streamer. The reason being is that the internal Wi-Fi of the Raspberry Pi actually screws up the DAC. So the internal Wi-Fi needs to be disabled for the unit to function at maximum performance, which is one downside of me using Raspberry Pi, because there's no way I can fix it, right? Because it's not my product. So yeah, so the stream is Ethernet only, and you can add Wi-Fi capability to it using bridge. I list the recommended bridges on my website for both 2.4 and 5G.
I learned something new today. Thank you. Well, many new things, but that one was pretty interesting.
Okay, last stupid question for me for the day. So, Leo, I know you're working on an integrated, or is it a preamp that's basically going to be without the DAC, but again, able to drive your amplifiers, obviously, but it'll have multiple inputs in that. When you do this buffer for tube preamps and stuff like this, would you be able to sell that as like an add-on for anybody that's already got your amps, that they could just plug it as an in-between their preamp and your amp?
No, it's going to be built into the same board.
Okay. All right.
So yeah, it won't be like an add-on. It's just when I manufactured the new BOSC or Star Crimson, it's going to be Star Crimson Mono is what it's going to be called.
Okay.
It's going to have 40K input impedance already built in.
Nice.
It's going to be built in, so it's not. I can't make it separately.
Yeah, no, the squirrel cage is going off in my head. That's the only reason I asked.
Yeah. But no, I'm not planning another. I do have the integrated amplifier, which is already a product. That's my most recent product, but I'm not planning any other preamp or any other products at this time.
Cool.
Yeah, I just got a lot of pushback on the input impedance of the amp, so it's something that I believe is holding the product back. So that's why I'm making it higher input impedance.
No problem. Cool.
Well, Leo, thank you so much for your presentation today and for your generosity in loaning us those amplifiers to demo. And I know they're making their rounds, and the folks that have used them have enjoyed them very much. I think I'm last on the list and eagerly await their arrival at my home. But anyway, thanks again. I know it's late where you're at, so I don't want to keep you too long. But I appreciate the time today, and giving us a little window into your business, and then talking to us about the technologies that you've developed.
Okay, yeah, you're welcome. Thank you for everybody's time as well. And if there's enough interest amongst your group for my other products, we can do a tour of those as well. And I didn't realize that. I guess that Ron had the integrated amps set up in his store, so maybe some of the other guys can go listen at the store if they're interested.
Yeah, so I think he's gonna do a YouTube review of your integrated amp very soon. It's just that he's got a ton of shit over at his place. Some good shit, some bad shit, but No,
yeah, I didn't realize he actually had like a storefront that he also ran a store.
Yeah, no. It's his is mainly just the YouTube channel, right? And but yeah, I mean he's now a friend of the club, so it's come in handy already a couple of times. And
okay.
Yeah, that's basically it for me.
All right, well then we'll conclude. Thanks everyone for joining us. Have a great weekend and, stay safe and sound.
Hey, Leo,
Okay.
say hello to Gobina for me, man, when you see him.
Okay, all
When you
right.
cross his path. Thanks,
All right.
man.
Thank you, guys.
All right,
Bye.
bye.